Okay, welcome to our Zoom Q&A with Professor O'Rourke of Cornell University and Martin Bureau of Senexen. So gentlemen, thank you very much for the webinar we just saw. It was very lively and it's greatly appreciated. So we already have a few questions. It is clear that you've invested time to better understand and measure the environmental benefits of your technology versus open cut. Now, just understand, open cut means basically changing the pipe, if I understand correctly, cutting a piece out of it and replacing it altogether, whereas your technology covers the inside of the pipe, recreating the pipe from the inside. Am I understanding that correctly?
Yes, you are. That's
okay,
exactly
good.
it. Yeah.
Okay, from the outsider's perspective, seems it's coming across. So can you speak about the benchmarking process? Have you evaluated if a city like Los Angeles could replace, let's say, 500 miles? What would be the benefits?
First, greenhouse gas emissions will be reduced significantly since both from a manufacturing standpoint as well as from a construction site installation, digging in and out the soil and everything, and then moving that soil around to a landfill. All this considered, and the fact that you need to reopen the whole street and not only pits to access the pipe, you'll save excessive amount of greenhouse gas emissions. Just to give you an idea, if Los Angeles in their program right now would use our technology instead of open cut completely for 1 year, they'd save 70,000 trucks on the roads of landfill, 70,000 per year. So that's a very clear output in terms of both traffic nuisance and as well as greenhouse gas and landfill and streets that are not open and so on.
I know this might be a bit of a broad question that you may have already answered, but what could be future applications of your technology?
Well, there's a lot of future applications. Not only is the technology amenable to improving pipeline performance because it rehabilitates the pipeline from the inside in situ without having to dig up the streets. It also is adaptable to a number of things. I mean, one of the areas that we at Cornell are very interested in is trying to create a smart infrastructure that can get smarter with time, not just frozen in the time that it's been constructed. And there's real opportunities, we think, that with the Senexen product to maybe embed fiber optics and so forth that actually creates a feedback mechanism for obtaining information and using the pipeline system as the penetrators of the urban environment to get this information not only valuable to the actual pipeline that's being monitored, but also valuable because not only do you monitor the actual pipeline, but because the pipeline's buried in the ground, you monitor the ground which is in communication or close to the pipeline. And therefore, data is the new oil. So you have the opportunity to acquire a lot of data. And I would think that that might be a future application and development.
Wonderful. And not only for water, but as well for gas applications, industrial applications. There's many type of applications where these smart infrastructure components could be applied.
Martin, where is this technology actually produced?
It's currently produced in Canada, in the province of Quebec, completely. So far, the plant that we have in the Eastern Township of Quebec, just across the Vermont border, suffice for the demand we have. This is a plant where we invested a lot of money up to for the last 15 years, since 2009, 11 years. Officially $27 million in that plant.
Wow.
That's the official number. And it's right now state-of-the-art, world-class plant of manufacturing, a weaving plant, of course. The way it was designed, we invested and improved on the production scheme and its state. You can copy and paste it somewhere else. So the minute the demand is there, we are able to build a new one where closer to our big markets, mainly in the US probably. Mm-hmm.
Speaking of other markets, are other countries interested in your technology?
Sure. Lots of them, as a matter of fact, in Europe, UK, Australia is big, New Zealand, where Professor O'Rourke had a sabbatical recently. They're fond in all sorts of seismic resiliency studies and applications. Perhaps, Tom, you could speak to that in particular.
You know, we see worldwide usage to create resilient infrastructure. And resiliency in this context is not only earthquakes, but anything that can generate movement of underground facilities. So that actually might involve hurricanes or floods. It might involve excavation or construction-related ground deformation. It also can be related to subsidence associated with groundwater withdrawal, or mining subsidence, or subsidence associated with withdrawal of gases from various locations. And those sources of ground deformation can be combated or countered by having pipelines which are flexible, that can sustain movement when there's movement imposed upon them by the external environment. And that virtually applies to every city in the world. Some cities that have ground movements more related to earthquakes, but there's others that are vulnerable from hurricanes, and therefore would be interested in a technology like this to be able to sustain deformations associated with the hurricane events, and on and on. So there's quite a lot of applications.
One new that we see with the climate changing is permafrost, the soil that's always frozen up till now in the northern regions. While it's melting, that creates a lot of movement, and they have infrastructure that need to be protected. So that would be a wonderful application in particular. But there's many of them.
You know, there's cities like Montreal and Toronto, you know, tough winters, that have already integrated the technology, making them pioneers. Now, with their deteriorating drinking water assets in other cities, do you have cities in particular in mind that would benefit from this technology?
Well, we can list a lot of the cities in the United States, for example, that would benefit tremendously because of earthquakes. Major cities along the West Coast, going from south to north, you could get San Diego and Los Angeles and San Francisco, both the east and west bays locations. You have Portland, Oregon, you have Seattle, Washington, and you have Vancouver, Canada. So just there are a lot of people. New York
Earthquakes are essentially the biggest threat to pipes. There's the cold, of course. There's the movements of the soil that happen naturally, but I can't imagine a worse threat to the functionality of these pipes than an earthquake. Am I wrong?
That will generate the most difficult ground or movements within the pipe to accommodate the ground movement, the most difficult differential movements that do exist.
So any city basically all over the world that are dealing with earthquakes on a regular basis, which is most cities, although some have much worse earthquakes than others. So any of those cities would be wise, let's say, to adopt the technology.
That's correct. I mean, a good example is underground construction. So there's a lot of cities that may or may not be associated with earthquake vulnerability that are expanding their metro systems or getting larger in terms of underground construction. And one of the opportunities when this construction occurs might be associated with expansion of the system stations. Sometimes the stations are added after the tunneling has gone through. And when you add the stations, a big cost is related to relocating all the utilities. And these utilities that have been reinforced with cast in place pipe can tolerate ground deformations now that would be generated by the construction, and can be kept in place, or they can be kept pretty close to where they were without having to move large distances. And this can cause, or can be result in quite a bit of savings. That's just one example.
I am going to close this off with a question again to you, Professor O'Rourke, and I'm sure Martin will have something to add to this. I'm just curious for myself, are other traditional pipe manufacturers as involved with the testing as you found Cenexen to be?
Cenexen has been a wonderful sponsor and a client.
Thank you.
And extremely interested in the reasons for why things happen. And so we've had a really good relationship. We've been fortunate at Cornell because there are lots of products that we're able to test over the years. And there's lots of interest on the part of the manufacturers and the developers of this technology. So we've gotten a good opportunity to work with a lot of different people. We're very happy to have worked with Cenexen also, as well as with our other clients. And we find that there's a genuine interest in improving underground infrastructure, and that bodes well for in providing technologies which allow cities to get better at what they do, manage their assets.
Just a word to complete what Tom very correctly said. There are many great solutions out there, and not, I mean, it's inconceivable that only one is the right option. It depends on the specifics of the requirements. When it's a context of open cut of brand new infrastructures, there are great products that have been tested and validated at Cornell, and they should be used. When there's there's no need for such significant work and replacement work, then our product and others have gone and showed a lot of benefits for the users. So it's really a case-by-case approach that will tell what makes the most sense for at the end, what is taxpayers' money. I mean, it needs to be well spent and get the most out of it. We believe that in some cases we are the best option.
Well, I can't really imagine you not being, after everything I've heard. You know, the resiliency of these is just beyond belief and beyond testing, really, because the work that you two have done together to prove the incredible resiliency of these pipes is, it's fascinating to watch from the outside. You know, from my perspective, it's very impressive. So unless you have anything more to add, I would simply thank you once again for joining us, and we'll see you soon, I hope.
For sure. Thank you very much.
Thank you, Jason. Thanks a lot. And Martin,
thank you.
Nice to see you too.
Thank you very much, Tom. Thank you, Jason. Thank you, everyone.
Okay, thank you, gentlemen. All right, so that was our final episode of the Cenexen webinars. I'm Jason Rohde, coming to you live from nomadlife.tv, our creative studios here in Montreal. It's been quite a journey, 6 episodes overall, that have introduced us to all sorts of Cenexen experts. And really, it was a real learning journey for me as well, understanding what Cenexen does, how they apply their technologies to real-world problems today. It was also interesting to experience all of this during the pandemic through Zoom, seeing how the company was proactive rather than just simply reactive to this kind of crisis. They were there on the ground, keeping their employees safe and our city safe. In the case of Aquapipe, with good drinking water. We hope we find you again in a couple of months when we'll be back in another format, hopefully, meeting these experts in person, bring the cameras on the ground to really show you the impact of the SenXN technologies that we shared with you throughout the season. Thank you for being with us, and we'll see you again soon, I hope. Stay safe.